Hi all. Let me introduce myself in the first place. I am Bishra and I'm industrial engineering student at Marmara University. And today we will learn Simplex Big M Method. And as you know, operations research lecture is very important for industrial engineering students. And also the Simplex Big M Method is very important for this lecture. So let's start with the learning Simplex Big M Method. Simplex Big M method, we have to know two words about this method, an artificial solution and the slack and artificial variables. First of all, what the artificial solution is. LP in which constraints are less than or equal to sign with non-negative right-hand sides offer a convenient all-slack starting basic feasible solution, but models involving equal and greater or equal to constraints do not. In this case, we use artificial variables that play the role of slacks at the first iteration and then dispose of them legitimately at a later iteration. Two closely related methods are the Big M method and the two-phase method. And today we analyze Big M method. And M method starts with the linear programming in equation form. If equation I does not have a slack or a variable that can play the role of a slack, an artificial variable, which is Ri, is added to form a starting solution similar to the convenient all-slack basic solution. And we have 5 steps to solving a model. And first of all, we modify the constraints so that the right-hand side of each constraint is non-negative. This requires that each constraint with a negative right-hand side be multiplied through by -1. And second step is identify each constraint that is now after step 1, and equality or greater or equal to sign constraints. And third step is convert each inequality constraint to standard form. This means that if constraint has a less than or equal to sign, we add a slack variable. And if constraint has a greater or equal to sign, we subtract a surplus variable. And fourth step is M is denote a sufficiently large positive value. The objective coefficient of an artificial variable represents an appropriate penalty if we have a maximization problem. We add -m, and if we have minimization problem, we add +m. In the last step is each artificial variable will be in starting basis. All artificial variables must be eliminated from row 0 before beginning the simplex. This means consistent form. And we will solve a question about this method after this video. So thank you for listening to me and see you all in the next question video.